Hello everyone and welcome to our presentations on the case study titled Computer Network and Security for the FK593. Our team consists of 3 members, myself, Pansingin Chloe, along with Noor Aisha Asmida binti Asli and Noor Kuaila binti Rizwan, and our lecturers, Madam Rosmawati binti Zafar. In this video, I will present our case study on DNS traffic analysis using Wireshark. Step 1, we started by using DNS capturing the DNS traffic. We opened Wireshark and selected a network interface with a live traffic. Step 2, at the command prompt, we flushed the DNS caching using ipconfig/flush DNS to remove any old record. Step number 3, we used an slookup to enter interactive mode. Step number 4, we entered domain name of a website. Our default DNS server was pspsvrad01.psp.edu.my. We then queried www.cisco.com. The server returned a non-authoritative answer with an IP address with alias record. Step number 5, we exited from an slookup and closed command prompt, then stopped the packet capture. This will give us a clean set of DNS packet to analyze.
Hi, my name is Noor Aisha Asmida binti Asli. My metric number is 10DIT23F2006. I will explain part 2, identify DNS query and response behavior. The first step is selecting the DNS packet level standard query in Wireshark. This allows us to identify the queries sent by the system for domain resolution. In our example, we use the domain www.cisco.com for analysis. Next, we expand the Ethernet 2 session in Wireshark to view the packet details, including the source and destination addresses. This helps us track where is the packet original from where it's being assigned, allowing us to see the flow of DNS traffic across the network. We then expand the Internet Protocol version 4 session to observe the source and destination IPv4 addresses. By analyzing their addresses, we can confirm the routing path taken by the DNS packet and check whether they align with the expected network topology. Next, we expand the User Datagram Protocol session to view the source and destination ports. In this case, DNS typically use port 53. By monitoring this port, we can understand how the DNS traffic is managed and ensure that it's being processed by the correct service. Following the capture, we open a command prompt and use commands like arp-a and ipconfig to record the MAC and IP address of the system. This system is important to link the network traffic, the specific device, ensuring we capture accurate information for analysis. Next, we expand the domain name system query section in Wireshark to explain the flag and queries. By analyzing the flag, we observe any critical indicator, such as the query is a standard query or if there are any flags related to DNS anomalies or potential attack.
Now, let me take over for part 3, where we apply DNS traffic analysis to identify vulnerabilities that could lead to network attacks. In this part of the case study, we focus on understanding how attackers could exploit DNS traffic. Step 1. Select DNS response. We select the corresponding DNS packet label standard query response. This allows us to analyze the DNS server's response to the initially query and determine whether the response was legitimate or potentially manipulated. Next, we expanded the flags queries and answers section within the packet details to observe the DNS response behavior. We check if there were any sign of manipulation, such as unusual flags or unexpected responses. Next, we expand the domain name system response section. This helps us see the flags, queries, and answers in the DNS response. Observing these details is crucial because they show us how the DNS system processes the response. If there are any discrepancies in the flags or answer, they could indicate problems such as DNS poisoning or manipulation.
To mitigate this risk, we discuss practical network security measures such as implementing DNS SEC to add digital signature to DNS replies using packet filtering firewalls and segmenting the network to protect DNS server. Monitoring tools like IDS or IPS can also help detect unusual DNS traffic.